In this video, I'll talk about some specific types of reliability. So first, let's review the definitions for reliability and validity. Reliability refers to the consistency of measurements. Validity refers to the accuracy of measurements. Here are some specific types of reliability that we'll cover in this video, validity, which we'll cover in the next video. So I'm going to go ahead and start off with test-retest reliability and work my way through the different types of reliability here. Test-retest reliability refers to the consistency of a subject's scores across repeated testing sessions. So basically, if you give the same test or the same questionnaire to a person multiple times, how consistently do they produce the same answers? And we can use either correlation or intra-class correlation, which I'll explain in a moment, to assess how reliable something is in terms of its test-retest reliability. And we'll actually use correlation for this with our GEQ data in class. GEQ meaning the group environment questionnaire that we took in class that measures 4 dimensions of team cohesion. Intra and inter-rater reliability are somewhat similar. So intra-rater reliability is the consistency of one individual rater or researcher in terms of assigning the same score for the same observation over multiple testing sessions. So basically, how consistent is the individual researcher at giving the same rating for the same thing multiple times? Inter-rater reliability refers to the same idea but with different researchers. So let's say there are 4 researchers working together. Basically, how consistency do the ratings from researcher 1, researcher 2, researcher 3, and researcher 4 relate to one another? If they're all rating the same observation, basically how consistently do they rate that situation? And again, we can use correlation and intra-class correlation to assess this. So intra-class correlation measures the extent to which scores are clustered. How closely are they grouped together, basically. So in the table here to the left, we can see that there are different ranges of ICC that reflect excellent, good, moderate, and poor reliability. And if we look at the graph over here to the right, this just kind of shows how this would look graphically for an ICC of 0.91, which is considered excellent. So if we think about each of these, basically each of these lines, 1, 2, 3, etc., it says group number, but we're not talking about study groups. We're talking about groups of data. So it could be, for example, it could be, like I said earlier, 4 different researchers rating the same thing. So this is from like these 4 different researchers or these 4 points. It could be intra-rater reliability. It could be the same researcher, but looking at something 4 times. Or it could be like a test-retest situation where we're giving the same questionnaire to somebody 4 different times, like basically a month apart, month 1, month 2, month 3, month 4. So there's lots of different ways we could look at this. But basically, how clustered are the data? And what we see is, generally in this graph, they're pretty close together. We see like here and here specifically, they're very much clustered together. Here a little bit less so, a little bit more spread out. But overall, you know, if something is rated low, it's consistently rated low, like we see over here with group 17, or 16 I should say. If it's rated high, generally it's consistently high, like with group 19 and group 8. So what would it look like if we had poor reliability? It would look more something like this. So this is an ICC of negative 0.07, so pretty close to 0. And what this means is that there's basically no consistency among either the different raters or the individual rater across different time points, or the subject taking the test over multiple time points, sometimes high, sometimes low, sometimes somewhere in between. generally very spread out in these different clusters. So this would reflect poor reliability. Internal consistency is a type of reliability that refers to the consistency of multiple observations that are proposed to measure the same construct, producing the same scores. So what we saw when we took the GEQ in class was that there are 4 different dimensions of team cohesion. Each of those dimensions has 4 or 5 questions on the questionnaire. So those little clusters of questions are worded slightly differently to one another, but they're basically all trying to measure the same thing, whether it's group integration social, group integration task, and so on. So basically within those sets of items, the scores from participants should be highly correlated. And we can use something called Cronbach's alpha to assess internal consistency. So like what we saw before, there are different values that refer to excellent, good, acceptable, questionable, poor, and unacceptable internal consistency. And we'll look more at an article by Eyes et al. From 2007 about the GEQ. This is specifically about, what happens when we change the wordings of these questions that we saw in the GEQ from the original version that we saw to all positively worded questions, like basically questions that don't require any reverse scoring because they're all worded the exact same, or in the exact same direction. They're all worded positively. So that basically high scores refer to high levels of cohesion. So this just kind of shows a correlation table showing the, and also it has a column with the alpha values that I talked about on the last slide. So basically just showing the different levels of internal consistency across these different sets of questionnaire items on the GEQ. So we'll talk more about this in class. Parallel forms reliability comes into play when you have different versions of the same test. Basically, how consistently do different versions, such as version A and version B, produce the same scores if given to the same subjects? So this is sometimes relevant in academic testing situations where you have different versions of the SAT, the GRE, for example. And like we've said with earlier examples of reliability, we can use correlation and ICC to assess parallel forms reliability. Standard error refers to the precision with which instruments are calibrated. This may be particularly useful when you're using certain apparatuses in your procedures. Often this is more relevant in laboratory settings. For example, one of my recent students was for her master's thesis was using a pitching machine to deliver baseball pitches to batters and wanted to ensure that that machine was delivering pitches consistently with the same speed. So what she did was she collected some data on the speeds of the pitches and she calculated the standard error. And what we want is for the standard error to be as low as possible because that's going to reflect that there's not very much variability in the speeds of the pitches. So basically they're as consistent as possible. So that is all for the different types of reliability. So I'm posting the definitions of these. Make sure that you begin studying them for the final exam. Make flashcards either on paper or electronically, whatever you think is going to work best for you. And that's it all for now. I'll see you soon.